Welcome to TubeAmpRepairShop.com, the place to bring your tube amplifier to get serviced. We offer a free inspection of your amplifier to determine if it will need tubes or other service. You can find us on the web at TubeAmpRepairShop.com or give us a call or text at 818-645-1075. In our last session, we removed the screws from the back panel, so there are a couple in here. We're going to have to take them out. Shouldn't be too difficult. There's one. Here's the other one. Alright, we've got the back panel off. A good place to start. I've already been in here and tested the tubes. Client that brought this to me said that it wouldn't bias. This model has bias potentiometers here. There's a total of 6 tubes, so there's an A side and a B side. It's a mono amplifier, so it's not left and right, just that there's 2 rows of 3 tubes that each have their own bias adjustment. When we power it up and we get ready to bias them, the red light will indicate over biasing or under biasing, and the green light will happen when we get just to the right place. I've got the tubes and screws already in the bag. I'll open up the tube tester a little bit later, and I'll show you the readings on the bad tube that set it off. Most of them are pretty close to good. And as we all know, with tube amps, you want to have the best match set that you can get. When the tubes are matched, you can have the best performance out of a tube amp. Often they're not matched perfectly, but as long as they're pretty close, you're going to have great results. And when you order them, when you purchase them brand new, you pay a little bit extra to get the matched ones, where they put them in tube testers, match the performance as closely as possible. So this is a match set. Now this amp uses one 12AX7 and 2 AU7s. And we're going to replace these also. I'm pulling out the preamp tubes. I'm going to just set these aside for the moment. I'm looking at the base to see which way they go in. We can see the pins are a little bit corroded due to age. This amp has been in service for 10 or 12 years with the owner that brought it to me. And so the new tubes should have cleaner pins, and that's always a good thing. These tubes, when I tested them, show as used. They're pretty good, but since we're going to replace the power tubes with brand new tubes, put in brand new preamp tubes as well. Now, let's see, got another bag in here. When I take amps apart and when I come back to them, I always put the large parts, screws, nuts, bolts, pieces, tubes in bags so I don't lose track of them. This amp is completely filthy, and I'm pretty excited. I bought this vacuum. You've probably seen it in the other videos, which will let us get some of the dust out. May not be able to get it to be spotlessly clean, but certainly get it to be better than it is. So here it goes. It's got this cool brush. Actually, it works wonders to get the dirt detached and then it's sucked right up into the unit. It's important to get the dust out of amplifiers. The thing about compressed air and canned air is they just spread the dust all over the place, which is why I like the vacuum. The vacuum collects it all into a filter, and then we can neatly dispose of it later. Not going to be able to reach entirely inside of the amp without removing it from the case. So if we don't actually have to remove it from the case to do the biasing, we won't be taking it out of the case today. We'll do the best cleaning we can with what we can reach. And so far, so good. This thing is really definitely working. I may be able to include a link in the description where to order one if you'd like to have one for your own self to work at home or in your shop. I biased a number of these Ampeg amps over the years, and it turns out there's quite a lot of different models. But at the end of the day, they do have in common that there's usually 2 rows of 3 tubes, and you have to bias them for each row. Well, that's the best vacuuming I can do for the moment. I've got the blower on now. Let's see if we can blow out any of the remaining dust. Seems to work best cleaning with the attachment with the little bristles. They loosen the dirt up and it gets sucked away. Alright, well, it's a good start anyways. This was a good investment. I definitely like being able to get the dirt and dust out. Sometimes the very powerful vacuums that we have is just too much for an amplifier. You got little parts in there and you don't want them to get sucked up while you're cleaning. Alright, so I'm going to go ahead and unwrap the tubes. Pretty exciting. Today we're using tungsol tubes, which are fabulous. Hopefully we can see them up here in the other camera. These are the preamp tubes, so that's 12AU7. And then these boxes are pretty large. I got to take them apart first before I can put them in front of the camera. These are 6550s. Very, very powerful tubes. Used in a lot of amps. Some Marshalls that are very loud have the 6550s in them. We all know that a lot of Marshalls have the EL34s in them, which are a great tube. So many great tubes. Marshall sound is classic. There we go. Tungsol electric tube. And that's a 6550. So we got 6 of them. I'm going to go ahead and unbox them now. Pretty exciting. When you put new tubes in an amp, it just comes to life. I won't talk too much about how tubes work in this video. I will do it in another video. But I'll comment that used tubes, sometimes they just fail, and that causes problems with amps. But also when they get old due to heat and usage, inside the glass tube there's metal parts, and there's a chemical painted on them. And it's that chemical, when you put it in a vacuum, you give it high voltage between the cathode and the anode. The anode is the plate. The cathode is negative with respect to the anode. It's a lower voltage. The electrons are emitted as a cloud and travel across the vacuum, and the plate's in the middle. Amplification occurs when your guitar signal or audio signal is fed into the grid, and then it's reflected in the high voltage output. Let's have a little bit closer look at one of these tubes. These are beautiful tubes. It's a interesting shape, and I don't know if you can read the writing on them, but it says 6550 tungsols, made in Russia, and they're pretty neat. Got a whole bunch of them here. Go back to the other camera and get a better shot of the whole process going on. So here we go. Start by putting in the back row of power tubes first. on the bottom of the tube. Of course, everybody already knows this. Just for anybody who doesn't, I'm throwing it in there. There's a little pin on the, it's a key that's located on the side of the tube. So when you rotate it, see if we can get a good shot of it. There it is. It's a ridge that sticks out, so that when you rotate it into the socket, it'll be in the correct orientation, and then all the pins will receive the right electricity. Every tube, well, some of them have the same pinouts, but often they're different. So you got to have 2 pins for the heaters, and you have to have pins for the plate and grid and all different kinds of tubes. So there's different pin configurations. This one's going in there, seating properly. Spring retainer is working. That's not going anywhere. Can't go very fast with this amp in any direction anyways. It weighs as much as a small armored tank. I don't know what it weighs in pounds, but just lifting and carrying it, you do need a crane. It's pretty heavy. All right, there's 2 of them in there. You know what? They sure do look beautiful. If you're a tube amp guy, then new tubes look beautiful. So, of course, I'm rotating it carefully until the locator pin has got the tube in the correct orientation. Right pins and the right holes in the socket. And we have the back row of tubes in. We're getting ready to do the front tubes. These are a little easier to reach. Trying to make sure they're well seated before I put on the retainer clips. It is nice that the retainer clips will keep them firmly in place. And that's 4, 2 more to go. And the locator pin on these seems to be facing right towards me in the front. Of course, make it a little easier to find. These metal clips on the sides, you can always bend them just a little bit so they fit the tube. Even though these have the shape where they're a little smaller at the top and wider in the middle, some 6550 tubes are straight up and down. Retainers have to be flexible, so you have different shaped tubes that have the same model number or tube number. They can attach to all of them. I think we're in good shape. That was, don't want to say too easy, but basically it was. Everything went right in the first time. Didn't fight me at all. They appear to be well seated. You want them well seated because if they're not, and a pin is sticking out, they can lose bias, run hot, and that's a bad thing. Here's the 12AX7. On the amp, it's nice. They are clearly marked on this on the panel. So the AU7 in position 1, AU7 in position 2, and 12AX7 in position 3. Here's these are tungsol tubes also. A lot of people like the JJs, and for guitar amps they work fabulous. Tungsols cost a little bit more, and I think they're worth the extra money. In this case, the client said, let's put the tungsol preamp tubes in there as well. So that's a matching set, and I feel good about it as well. So here we go. There's the middle tube is a 12AU7. That's seated nicely. Good quality sockets. When you put them there, you can feel they're not floating around or loose at all. They're making a good connection. That is important. Okay, so the retubing is basically done. One of the things about biasing amps, you want to make sure all the knobs are turned all the way down. So double check to make sure everything is turned all the way down. And then the other thing is, anytime you have a tube amp, you have to make sure it's plugged into a speaker load. In this case, I have a box on the desk that you can't see because the amp is blocking it, but it's especially set up with heavy-duty resistors. A lot of techs use the smaller resistors, the metal ones that can take 50 or 100 watts. I went all out, I bought a Hammond case, and then I installed 3 resistors, one at 4 ohms, one at 8 ohms, and one at 16 ohms. And they represent a load to the amplifier, so that you don't have any problems with if you don't have a speaker hooked up and you turn it on, it can cause problems with your output transformer. So let's see, speaker out, here we go, 300 watts, and it doesn't specify the ohms needed, but most bass cabinets are either 8 or 4. There's a switch on the back for 2 ohms or 4 ohms. It's currently set in 4 ohms. Well, it's probably meant to go with an 810 speaker cabinet, and then if you have 2 810 speaker cabinets in parallel, if you use both jacks, that's parallel, then the amp would be seeing 2 ohms. I'm going to switch my box over here with the resistors. These have a banana clip, so I could just slip out of one and into the other, plugging it into the 4 ohm. So now the speaker output is plugged into the 4 ohm output, and we'll be able to see it up on the oscilloscope once we get it powered up. Alright, time for a power cable. We got the power cable here. Now, I don't know if you can see it with the camera at this angle, but I do have a variac, which is down here in the corner. It allows me to turn the voltage up and down. And more importantly, up at the top, there's a current limiter. Current limiter has a light bulb. When you first turn it on, there's a switch to stay in current limiter mode. If there's any kind of a short or a problem or something that isn't working and it's drawing too much current, the light bulb will light up very brightly, and then you know to turn it off. This saves fuses and stops the amp from having problems with too much current going through it. So I'm going to plug into that, and then after we're sure that it's operating, without drawing too much current, then we'll take it out of current limiter mode and perform the bias with it turned all the way up. There's 109 volts. I can adjust the variac to be a little bit higher. Electricity is coming through. Set it for 117. I know sometimes wall outlets are up to 122 now. When I put on the current limiter, it does drop the voltage down a little bit, but that's normal. It's running it through the light bulb. So some of the voltage is running away. Definitely have the correct voltage without the limiter in the middle. Okay, so it's safe to plug the amp in. I'm going to go ahead and plug it in. Make sure the amp is in the off position to start with. It is. Tubes, of course, need to warm up. In the book, it says 14 seconds is the standard expected for tubes. We're going to let them warm up a bit more than that. Okay. Well, I don't see any light coming up on the current limiter, so far so good. I guess I'm going to take it out of current limiter mode. There we go. Now I have enough voltage for this amp to operate. I'm looking to see. When you turn the first switch, you should see the heaters come on. It allows the 6 volts, which is standard for most of the tubes, to warm up the cathodes. Let's see. Yep, I can see them glowing. And then when we throw the standby switch, that puts the high voltage on. I'm going to go ahead and take it out of the current limiter, just plug it into the regular electric strip. Alright, now we have at least the 117 coming up, which is pretty much what it's expecting to see. With the power switches on, the heaters are running, and there goes the high voltage. So now I can see the little orange heaters glowing in there. Got our speaker load. Using a small screwdriver to set the bias. Let's see what we got. Yep. As we increase the bias, we can see the little green light come on, and then the red one. So we just want to turn it up until we're green. Now we see the red one. We're going to back it off just a little bit. And there we go. It's biased. They certainly make it easy with the little light bulbs. Now we're going to try running a test signal from the signal generator into it. I'm going to put it in standby while I plug in the wire. I think I'm going to go ahead and turn it around so it's a little bit easier for us to all see what's happening with the controls. Stand by for a moment while I do that. Oh, we got the power on. Switch to standby and power fault. I guess that'll probably go off when we turn on the standby. It's the first time I'm looking at it. Let's see what we got. Turning the gain all the way down, master all the way down. Leave the EQs somewhere in the middle. Okay. Ultra high, ultra low switch. Feeding it a very small signal. There's two inputs, one at 0 and one at minus 15 dB, which I gather is for the active bases. Alright, so we should have a waveform. Now we do. If you're able to see over here on the oscilloscope, I'll turn it up a little bit more. We'll adjust it. We have a very, very clean sine wave happening. Let's say we got lots and lots of headroom here. If we turn the master up and the first gain down, yeah, that's very loud. It's about at 6. I'm sure that it's enough to make anyone deaf. And the gain is set at about 3. Try the ultra low switch, the ultra high switch. EQs don't seem to change the gain a whole lot. So that's what we're looking at right now is gain. Treble does. That's because gain is usually read somewhere around 3. Well, I think it's time to try it with a speaker. So I'm going to find a speaker to plug in so we can hear it. And stand by and I'll be right back. I see the standby power fault switch. Now that the bias is set correctly, it changed from red to green. When I put it in standby, it turned red again. So, okay, right now the amp is off. I'll be back in a moment with the speaker. Alright, so we have the amp turned on, and we get a chance to listen to it. I have the volume set on about 2 and the master on 7. The mid-range is selectable, so I have it on one of the frequencies that's labeled 1 through 5. I got it on 1. Treble is set at 5. Well, the bass amp sounds fabulous, and let's see. You get loud? loud. I'd have to pronounce this amp working and in good shape. Well, I want to thank everyone for watching. This was a very successful project. We changed the tubes. We set the bias, both the A side and the B side of the SVT Classic Ampeg. 300 watts of pure bass power. And this amp delivers. Sounds absolutely fantastic through the giant speakers. Probably sounds best through its own cabinet with the 810s as originally intended. Those Ampeg cabinets are massive. This video has been brought to you by TubeAmpRepairShop.com, the place to bring your tube amplifier to get serviced. We offer a free inspection of your amplifier to determine if it needs tubes or other service, and set bias as needed. You can find us on the web at TubeAmpRepairShop.com, and you can call or text us at area code 818-645-1075. And we'll be happy to help you with all of your tube amp service and repair needs. Thanks for watching, and see you later.